Measurement and uncertainty is an important concept of physical science because it affects the way that we run our experiments and the tools that we choose to run our experiments with. The learning target for this lesson is, I can make measurements and rank the uncertainty of measurements. Two words that we can use to describe the measurements that we're making is precision and accuracy. Now, precision is how similar or close repeated measurements are to each other. For example, if I tried to take out a meter stick and measure the width of my desk, how often am I going to get the same exact measurements every time? Right? How often am I going to get those? That would be our precision. If we get them like often on our measure, we measure it 100 times and we get the same measurement 99 times, then we're very precise. We're getting similar measurements every time. Accuracy is how close our measurement is to the accepted value. So the accuracy part of this is how close is my measurement to the actual width of the desk that I was measuring, right? So the accuracy is looking at one of those measurements, and the precision is looking at how all of our measurements are similar or different from each other. So this visual is going to give a pretty good representation of accuracy and precision. So if we have accuracy, remember we're getting close to what the measurement actually is. So in this case, we'd be getting really close to the bullseye. If we were very precise, that means all of our measurements are really similar to each other. Whether they're close to the bullseye or not, we're getting the same measurement every time. And so in this case, this first one, we don't have good accuracy or precision. We're all over the board. In this top right case, anybody who's ever sighted in a gun before knows that this is a precise grouping here. You're gonna have to change your sights a little bit, but at least you're shooting well because all of your bullets are hitting close together, even though they're not quite on the bullseye. So you would know that your sights need to be adjusted a little bit. In this bottom left-hand corner, our overall grouping, if we took the average of how far all of these bullets were from the bullseye, we'd know that we were pretty close to the bullseye. But they're not quite as tightly grouped as we want them to be. So we have low precision here. That means that we're probably making an error. We're maybe a little bit shaky when we're shooting. And this last one, we're very accurate and we're also precise because we're not only in the bullseye, but all of our bullets are in the bullseye. And so we're making, if we were to translate this into a measurement, we're making the same measurement every time and we're making the exact right measurement every time. So as we're selecting our tools, it's really important that we choose tools that are going to give us the best option of being precise and accurate in our measurements. And so, to take it back to the gun analogy, if I was going to choose whether to shoot, maybe I was out deer hunting and I was trying to take, I don't know, maybe a 300-yard shot or something like that, I would much rather have a scope that I knew was sighted in as opposed to just shooting open sights at that distance. And so we can choose tools that are going to give us the best shot of making precise and accurate measurements. And it's the same thing whether I was trying to, maybe I was trying to measure with like a piece of string that had marks at 0 meters and 1 meters, as opposed to a meter stick that has markings all the way along it, breaking up all these little measurements and allowing me to be very precise. And we're going to see that in the next example. And so if we're looking at this right here, how many centimeters is this object, whatever it is? So I know that I have, I know I'm past 40. I know it's at least 41. I can't say that it's 42 yet because it's not past that 42 line. So I know I have for sure 41. Now, I can get into some decimal places here with these little millimeter lines. So I know I have at least 1, 2, 3, 4, 5, 6. I know I have at least 6, and I know I don't have 7. So I know I can put a 6 here. And now I can estimate the next digit here. So if I'm looking at this, I'm going to say that this is possibly a 4. Right? So as I made this measurement, I would say that this is 41.64 centimeters. And so the next person that came along, they'd say the same exact, they'd go through the same process and they'd go, okay, I know it's 41, I know it's 0.6 because I can see it's past that digit, and they would measure and maybe they'd say it's 46.3 centimeters. And we would actually be pretty precise on this because we have a lot of little lines making up that meter stick. And so our measurements, and then the next person come in would be even closer possibly. Maybe they'd say 0.64, and we'd be very precise because we chose a tool that allows us to be precise. And as we're making measurements for volumes, this is called a graduated cylinder. You can only see part of it. We can look at the same thing with graduated cylinders. So I look here, and this is a volume now for milliliters. So I know I have 10, I know I have 15, I know I have 20, and I know I have 21 right here because it's past that line. Now with graduated cylinders, we measure to the bottom of this right here. This is called a meniscus. Kind of like the meniscus that's in your knee. It forms the same shape, and that's how it got its name. I know I have 21, and now I don't have anything past that 21. I don't have a line, so I've got to take a guess here. I'm going to say this is 29 or 21.5 milliliters. Now I cannot say this is 21.54 because I don't know this number here, that 5. So I can't estimate past it. I can only estimate one past the measurement that I am certain about, and I am very certain that this is past 21 milliliters. So this would be 21.5 milliliters for my estimate. And when we're measuring mass, uncertainty becomes a little bit of an easier principle. We just take whatever measurement the digital gives you, as long as you've done everything right with making sure your scale is set up, your balance is set up, and your sample is set up. You can just take whatever number is off of there. So we don't have to worry about too much uncertainty there. We have very precise tools. But there are some scales that do go to farther place values. So maybe, if we bought a really expensive scale, we'd have something that goes 5.6789. Maybe it gives us 4 decimal places. We have to pay for those extra decimal places, but that is a very much more precise instrument than one that has 2 decimal places, because we can measure farther. And we can see that in this example here. So we're trying to figure out which of these has the most uncertainty. So which one of these is the least precise. And so if we look at this graduated cylinder, that's what the graduated cylinder looks like. Remember, when you're measuring your graduated cylinder, you should get your eye right down to the level so you're right even with those the meniscus, and so you can see very well. So we know that we have at least 60. We know we have 1, 2, 3, 4, 5, 6. I'm going to say that is right at 7. We're going to go 67, and I'm going to estimate 0.0 milliliters. Right? I can't guess any farther past that because I don't have another line. And so we're going to go 67.0 milliliters. Now, if we look over here on this one, I know that I have 1,000. I believe there's a line right here, and I don't think the meniscus is past it. I can see it's just a little bit under that line. So I know that I have at least 1,000. And I think that I am at 1,400. I know that's not 1,500. I know that's 1,400, and I'm going to assume that this is 90 milliliters. So I'm going to take that as my estimate. I know I have 1,000. I know I have less than 1,500 because it is just barely underneath that 1,500 line. And I'm going to estimate that 9. And so if we look at these two next to each other, 67.0 milliliters and 1490 milliliters, which one of these has the most uncertainty, or which one of these is the least precise? Well, this one over here has more decimal places. We would be, if someone else came over and made this measurement, they'd be way closer to us, more like a greater percent of the time. Someone else over here might think that that was 1,500, and some of you might have thought that it was 1,500, but I guessed that it was 1490. And so we would be off by a factor of 10 if someone said that they had 1,500, or not a factor of 10, but we'd be off by 10 milliliters. And if someone estimated a little bit differently on here, they might be 67.1, but we'd really only be off by 0.1. And so our certainty would be much higher because we are going to be more likely to get the same number. And so this one would have the most uncertainty because of the tool that it chose. And so when you're designing experiments, it's important to choose the tool that gives you the most certainty, right? Something like this that's going to give you the most decimal places for your measurements. That is appropriate. Obviously, if you're going to measure a bunch of liquid in graduated cylinders over and over and over, there's some other issues with that. But in this situation, this tool is the most. And so the learning target for this lesson was to be able to make measurements and to rank the uncertainty of measurements. And so hopefully you have an idea of how we need to make measurements, whether it's distance or mass or volume, and you can rank how uncertain these measurements are.